Hello, welcome to today's webinar. Today we're going to talk about the carbon footprint. What is a carbon footprint? How do you go about measuring a carbon footprint? The different methods or tools that are available to measure the carbon footprint. My name is Beth. I'm a member of the low carbon team at M-SParc, and this is my day-to-day work, really, measuring carbon footprints, life cycle assessments. So what is a carbon footprint? So it can be defined as the emissions of greenhouse gases as a result of human activity. Now, when we study carbon footprint, we often see the term global warming potential or CO2 equivalent. And what this means is it's a system developed to measure how much energy 1 tonne of gas will absorb in relation to a tonne of carbon. There are several different greenhouse gases. They all have a different global warming potential. They absorb energy differently, so for example with methane, that has global warming potential 25 times more effective at absorbing energy compared to carbon, and nitrogen is 298 times more effective. And then we've got the F gases, the industrial gases, and these have a global warming potential several thousand times more effective than carbon dioxide. So how do I go about measuring carbon footprint? So this diagram shows a simple product life cycle. We look at the entire life cycle. We need to look at where the items or the resources, the raw materials that are used, how they enter the system to produce an item, the processing that goes into doing these individual sub systems within the life cycle of a product, the manufacturing, so at the production facility, all the raw ingredients that come in and exit the system, distribution, use stage, and then the end of life, whether we recycle or reuse, how it's disposed, whether it goes to landfill or incineration. And every stage within this life cycle has its own individual life cycle in a way. To sort of put into a context that we can sort of look at today, I've got this example of a loaf of bread. So quite simply, this loaf of bread starts off with the cultivation of the raw ingredients. So as I was saying, there's the life cycle of each stage of the life cycle. So the cultivation, that would begin with treatment of the land. There's the applying the fertilizer, perhaps. There's the growing the seeds. There's tending to the crops whilst they're growing. Sometimes, depending where in the world these grains are cultivated, there could be irrigation required. Then there's the harvesting, and of course we're going to need some machinery to do that. So there's the tractors, they rely on diesel. So all these items within this cultivation stage need to be reviewed, and we need to gather that information in each stage. So from the cultivation stage, moving on to the processing. In this scenario, it's making flour, but then again, it's not. We've got the electricity for the processing facility. There's the energy that's needed, maybe natural gas or oil. There's the other raw ingredients like water. Then we transfer the raw ingredients to our processing facility, which is the bakery. And again, there's several inputs and outputs at this stage. So we've got the main ingredients, the flour coming in, then we've got the yeast, the water, obviously the electricity, the energy that's needed on site for the heating. So there's gas. There could be diesel, perhaps, for the maybe standby generators or something. There's the packaging stage. Now, when the goods are ready to leave the bakery, they are distributed using vans or lorries, using diesel, and then they're transferred to the consumption stage, which is we take the bread home, we take it out of the packaging, consume it, and then it enters the end of life stage. So the packaging goes into the recycling bin, maybe the crumbs go into the recycling bin, and they go into maybe an anaerobic digestion system. So that gives you a simple sort of idea of how we look at a life cycle and how we need to be quite detailed about gathering information and focusing on every stage of the life cycle to make sure that we've got a complete sort of list of items and inventory to use in the next stage of the study, which we move on to different methods of working out what is a carbon footprint. So here, this diagram here just shows us the steps involved in doing a life cycle assessment. So it's a simple diagram. And what we've got is in the first box, we've got the goal and scope definition. So this is where we define what is the purpose of the study. In this case, it's to evaluate the carbon emissions of a loaf of bread. We also have to decide what the system boundaries are. So how far are we going to look into this? So as in the diagram, the previous slide, we've got from the cultivation of the raw ingredients through to the treatment of the waste product. So it's a full life cycle. Sometimes it's defined as a cradle to grave approach. It's best to be, to focus on this cradle to grave sort of approach, because we want to be as complete and as honest as possible when we come to reporting the carbon emissions. So we've defined our goal and scope, we've got the system boundaries. Now we decide how we're going to discuss and present the results, so the functional unit. So in this case, we might say functional unit is 1 kilogram of bread packaged in maybe a paper bag and delivered to the retailer. When we've finished with the goal and scope definition, we can move on then to the inventory analysis. And the inventory analysis involves going through each stage of the life cycle, meticulously making a list of every item that we've got to account for, every piece of activity that could be responsible for carbon emissions. We need to make sure that we note them down. So again, if we think back to the scenario where we start off with the cultivation, we've got some perhaps some fertilizer that we apply to the ground before we start growing the crops. And we've got the crops that we need to account for. There's the diesel that's used in the machinery. There could be some irrigation, so there's perhaps electricity to operate the water pumps. Again, several different kinds of machinery that we might need to rely on in this stage, and they all will more likely use diesel for their operating. And then we go through that kind of approach for every stage of the inventory analysis stage. And when we feel we've got a full list of inputs and outputs to the loaf of bread scenario, we can move on then to the impact assessment. Now this is where we work out what is the carbon equivalent to each stage of each item we've got in our inventory. So for example, if we've got a certain amount of kilowatts of electricity, what does that mean in terms of kilograms of CO2? And we work through each item in the inventory analysis that we've compiled in the inventory analysis stage, and we work out the carbon emissions for each stage, and then we can totalize that, and we can work out based on our function unit what is 1 kilogram of bread equal to in terms of its carbon emissions. Also in this diagram we've got the big box that says interpretation. What that means is that at every stage in the life cycle assessment approach, we'll stop and we'll interpret. We'll go through the interpretation stage. We'll look at data quality, if we're happy with the information that we've collected. If there is something that we're not sure of, we'll step back into the previous stage. We might look at the inventory analysis. Something might not look right in terms of the impact assessment. We might have to check the data quality. And it's also important to sort of mention as well that better data quality, the more reliable the results. So often we'll start with 12 months of data for our inventory. But then we can work out what does that mean in terms of per kilo of bread. Maybe we'll say total electricity, then divide that by the number of loaves of bread or kilos of bread that has gone through the bakery. And that's quite simply how we go through the life cycle assessment method. There are several tools available for doing life cycle assessment. There's a free tool that can be downloaded called OpenLCA. It's quite a useful tool. There's a paid for tool which is called M-SParc. And for both of these tools, we need a database of processes. One company that can provide with this kind of information is EcoEvent. There's a database of tens of thousands of processes that we can use in EcoEvent, and that'll work in OpenLCA or M-SParc. It will also work with Excel if you prefer to sort of do a inventory and an analysis in Excel format. We can also extract the Excel impacts from OpenLCA as well, and it's very useful in terms of understanding what is the description for each process. So for example, the electricity, if by looking into the description on OpenLCA, it will tell you what is the description for a particular process. Then we've got the greenhouse gas protocol. This is the methodology that we can use to work out carbon footprint. This is a slightly different approach to the life cycle assessment. In this method, it's perhaps simplified in one way. And what we've got are 3 scopes. So the impacts are broken down into 3 different categories. So for Scope 1 emissions, this is the emissions that occurred on site at the facility. So if we look back to our scenario of the bread bakery, we've got maybe the gas for running the ovens, or maybe the fuel for the vans. So those would be the Scope 1 emissions. These are the emissions that occurred on site, directly responsibility of the business. Scope 2 emissions are the purchased energy. So if the electricity is the most common Scope 2 emission. Sometimes in industrial areas, you might be able to buy steam, but this is quite rare. And then there's the Scope 3. These are the up and down emissions that occur throughout the supply chain. So again, thinking back to the scenario with the bread scope, so the upstream emissions would be the cultivation, the transportation, and the processing of the grains to the flour. And then the downstream, obviously, the transportation from the bakery to the consumer, and then down towards the end of life treatment, so the handling of the waste at the end. It's often used to look at for Scope 1 and 2 by companies. Sometimes Scope 3 is a bit more of a challenging, it's a bit more difficult to collect Scope 3 impacts, because you have to go through the suppliers, and that's difficult to get information sometimes. But I think what's important to remember here is that this is just the first step. If doing a carbon footprint is something that you're tackling for the first time, it's not just a one-time sort of event. It should be something that you do every year. And the reason I say that is, as your company grows, as the business expands, you should be seeing improvements in terms of efficiencies, and that should also show, like, as efficiencies improve, the carbon emissions should be coming down, and that'll tell you if you're ongoing the changes and the process that you've implemented having a positive effect on not just efficiency, but on carbon emissions. So that was our brief sort of talk today about carbon footprint. I hope it's been useful. And if you've got any questions, feel free to send me a message here on my M-SParc email address. Diolch, thank you.